Hi students, welcome back to Applied Mathematics session. In this session, we are going to study about modulus inequalities. Okay, already we have seen solving inequalities, and we learnt about solving system of linear inequalities. Today, we are going to study about inequalities involving with modulus. Okay, we have already learned modulo, but today we are going to see about modulus. What do you mean by modulus of a given number or given expression? So, modulus of a number is denoted by, or modulus of an expression is denoted by modulus, two vertical lines. Inside that we are having the expression. Okay. Now, let us discuss in detail about this function. What is modulus of minus 5? Modulus of minus 5 is equal to 5. What is modulus of 3? Modulus of 3 is 3. Modulus of 3 is 3. What about modulus of minus 25? Modulus of minus 25 is 25. This modulus removes the negative sign of a number. It converts the given negative number to positive number. How it happens? We define modulus of x is equal to x when x is greater than or equal to 0. Whenever x is 0 or positive, then we take the value as such. But whenever x is less than 0, what do you mean by x is less than 0? X is negative, when x is negative, and it is defined as minus of x. That is why when you apply modulus, the negative numbers are converted to positive numbers. Okay. So, this is the rule of the modulus function, that is modulus of 5 is equal to modulus of 5. Now, the number 5 is positive, so we take the answer as 5 itself. Modulus of 100, that is equal to 100 itself, because it is going to be a positive number, it is more than 0. What happens when it is minus 5? The number inside the modulus value is negative value, which is less than 0. So, we have to multiply this minus 5 with another minus symbol. So, it is minus of minus 5 by this rule. So, this convert this one to positive. That is how the negative number inside the modulus symbol is converted to positive number. Suppose if I am having minus 100, what happens? Because minus 100 is less than 0, it is a negative number, we multiply with another negative. Negative into negative changes to positive number. So, this is the role of the modulus function. So, modulus of x is equal to x whenever x is positive or equal to 0, and whenever x is negative, it gives minus x as the solution. Okay. Now, let us discuss certain facts about the modulus value. Okay. Certain facts. First one, modulus of x is always greater than or equal to 0. the answer what we derive from modulus function is always greater than or equal to 0, and mod x cannot be negative. Modulus of x cannot be negative. The answer for modulus of x cannot be negative. Second one, modulus of x is equal to 0. Modulus of a number or the expression is equal to 0, then definitely your x value should be equal to 0. Okay. Third property, modulus of minus x will be equal to modulus of x. Okay, because modulus of minus 5 and modulus of 5 both will have same answer 5. Modulus of minus 100 will be equal to modulus of 100 and the answer will be equal to 100. Okay. Fourth fact, when the modulus and the number will be same, x is equal to mod x. When this situation will arise, x is equal to mod x. This is possible only when x is greater than or equal to 0. In that case, what will happen when x is less than 0? When x is less than 0, definitely your x will be less than mod x. So, this property we will be using while solving the inequalities. So, whenever x is less than 0, your x will be less than mod x. Next one, modulus of xy will be equal to modulus of x into modulus of y. Modulus of x by y will be equal to modulus of x divided by modulus of y. Let us solve a very simple problem involving with modulus. We are going to solve simple problem with equations containing modulus. Okay. We take modulus of x plus 5 equal to 3. What will be the solution for x which will satisfy this expression modulus of x plus 5 equal to 3? Which implies when we remove that modulus, your x plus 5 can be equal to 3 or your x plus 5 equal to minus 3, which implies we have to remove this plus 5 which appears with the x. How to remove? We have learnt in the previous sessions. We have to add by additive inverse of plus 5. Additive inverse of plus 5 is minus 5. So, it is 3 minus 5. So, which implies x is equal to minus 2. How to solve this expression? X plus 5 equal to minus 3. Again the same procedure. X plus 5 minus 5 equal to minus 3 minus 5. So, plus 5 minus 5 cancel. This is minus 3 minus 5. So, x is equal to minus 8. So, these are the two values of x. If you substitute in this expression modulus of x plus 5, the answer will be equal to 3. So, how to solve the equality of modulus expression? So, if you are having modulus of ax plus b is equal to k, then how to solve this expression? Because this is an equality symbol, your modulus expression ax plus b can be equal to plus k or minus k. So, we have to take it as ax plus b is equal to k or ax plus b is equal to minus k. then we have to solve for x. So this is with regarding to modulus and solving the equations involving modulus. Now we move on to solving the inequality involving modulus. So we consider this expression. Okay. Now we will discuss about solving inequalities involving modulus. Mod x is equal to a, which implies x will be equal to plus or minus a. This is the solution for the equality involving modulus. Now we can have different things. First one, modulus of x less than a. Modulus of x less than a. What will be the solution for x now? Now your x can be negative or positive. When x is positive, it can take the value from 0 to a. Okay, because here we are having a real number system, real line. Here we are having minus a and plus a. Is it clear? Now if you take this as modulus x is equal to a, then solution for this one will be x is equal to plus or minus a. Now your answer will lie to the left of minus a or between minus a and plus a and to the right of a. Okay. Naturally, for mod x is less than a, your solution will be between minus a and plus a. Minus a and plus a. Then only when you take modulus value, it will be strictly less than a. So your solution set will be x belongs to open interval minus a to plus a. For example, you can take mod x is less than 1. Mod x is less than 1. So if you take mod x is equal to 1, then your x value will be equal to plus or minus 1. We can draw this one in real number. Minus infinity to plus infinity, and we mark minus 1 and plus 1. Now my answer for this expression inequality can be here or here, or it can be here. How to find the value now? If I take any value here, minus infinity to minus 1, say suppose minus 2, what happens to modulus of minus 2? Modulus of minus 2 will be equal to plus 2, but 2 is not less than 1. So this is not the solution set. So my solution will not lie in this interval minus infinity to minus 1. Now if you take same condition 1 to infinity, if you take 2, again modulus of 2 will be equal to 2, which will be greater than 1. So we conclude whenever it is less than some particular value, it is going to lie within the interval. So your x belongs to inside minus 1 and plus 1. What will happen when the inequality is having equal to symbol? Modulus of x less than or equal to a. Whenever modulus of x is less than or equal to a, then minus a plus a, the solution is going to lie well within minus a and plus a. Because of the equality symbol in inequality, the endpoints also will be included. Endpoints will be included. So the solution set will be x belongs to closed interval minus a to plus a. So whenever we have the inequality less than or equal to, the solution will lie well within the given number. negative to positive value. What happens when mod x is greater than a? Modulus of x is greater than a. In that case, when you solve mod x is equal to a, we will get two values, one is minus a and other one is plus a. Then now which are all the values of x which will be greater than a? The values which lie to the right of a are all greater than a. So we have to choose this part. By symmetry, we can take this part also. When you take modulus of this part, that also will be greater than a. So the solution set for this expression will be x belongs to minus infinity to minus a union a to infinity. What happens when mod x is greater than or equal to a? The same thing, the endpoint should be included except for infinities. So when you take mod x is equal to a, we get the values as x is equal to plus or minus a. So we cut the real number system, minus infinity to plus infinity. We take minus a and plus a. Because mod x is greater than or equal to a, your x value should be greater than a. Positive value of x should be greater than a. Then it is going to lie on the right side of a, and endpoint is included. And for the next part, this region also will be, when you apply modulus, it will be greater than a. So the solution set will be now x belongs to minus infinity to minus a union a to infinity. So we come to a conclusion now. Whenever modulus of an expression is less than some value, then the solution of that expression will lie within negative value of the right hand side to the positive value of the right hand side. That is, when mod x is less than a, your x value will lie between minus a to plus a. When mod x is greater than a, then your x value will lie outside minus a and plus a. So this is the major thing we have to know to solve the inequalities involving modulus values. Is it clear? Now we are having two obvious things. One is, what happens when mod x is greater than minus a? Here a are going to be positive values. What happens when mod x is strictly greater than minus a or greater or equal to minus a? Then what will be the value for x? In such case, your x value will be r, all possible values of real number of x. The second one is, what happens when mod x is strictly less than minus a? I already told you, modulus of any expression is always positive, and to the worst it will be equal to 0, but it cannot take negative value. Now the expression says mod x is less than minus a, which is not possible for any real values of x. So this is not possible for any real x, not possible for any real x. So to solve the inequalities involving modulus, we must be knowing this concept. Mod x is less than or mod x is greater than. If it is less than, it will lie well within the interval. If it is mod x is greater than a, it will lie outside minus a and plus a. With this introduction, we are going to start solving the inequalities involving modulus function. Now see the first question. Modulus of x plus 3 less than or equal to 5. Now we are having 5. 5 is a positive number. So we can solve the solution. Find the solution for this expression. Okay. Now how to solve this? Whenever we are having mod x is less than a, your x value will be lying between minus a and plus a. Whenever mod x is less than or equal to a, your expression x will lie between minus a less than or equal to x less than or equal to a. Now how to solve this? It is less than or equal to modulus of x plus 3 is less than or equal to 5. Because it is less than or equal to, it is a bounded solution we are going to get. So it will be minus 5 less than or equal to x plus 3 less than or equal to plus 5. Okay. Now to find the value for x, we must remove this plus 3. So how to remove plus 3? We have to add the additive inverse of plus 3. So it is minus 5 minus 3 less than or equal to x plus 3 minus 3 less than or equal to 5 minus 3. So minus 5 minus 3 both are going to have same sign. So we add the numbers. So it is minus 8 less than or equal to plus 3 minus 3 cancel, x less than or equal to plus 2. Now what will be the solution set? Solution set is minus 8 closed to plus 2 also closed. So this is solution set. So while solving the system of inequalities involving modulus, the same process will be followed for all the problems when it is less than or equal to. Whenever it is less than or equal to, we have to take negative value of the right hand side, negative value of the right hand side less than or equal to the given expression less than or equal to 5. And whenever the middle term, we should not have modulus. We are not supposed to put modulus here. We have to take only the expression inside the modulus value. Is it clear? Because whenever mod x is less than a, we write minus a less than x less than plus a. Am I clear? We move on to next question. Now solve the inequality. It is modulus of 3 minus 5x less than 7. Now we solve another problem. Here we are having modulus of 3 minus 5x is less than 7. Now we have to see three things. One is we are having modulus. The second one, we are having less than symbol, and the third one is we are having a positive number on the right hand side. So we can find the solution for this inequality. Because it is less than symbol, the answer will be the bounded solution. So how to start the solution for this expression? Since we are having 7 and less than 7 is the inequality, so we write 3 minus 5x lies within plus 7 and minus 7. So minus 7 less than 3 minus 5x less than 7. We are supposed to find the value for x. For that, first we must eliminate 3. How to eliminate 3? We have to add the additive inverse of 3. Additive inverse of 3 is minus 3. So we get minus 7 minus 3 less than 3 minus 5x minus 3 less than 7 minus 3. In that case, minus 7 minus 3 is minus 10 less than 3 and minus 3 cancel. So we get minus 5x less than 7 minus 3. 7 minus 3 is 4. Next we try to eliminate 5. So how to remove 5 which is in multiplication, we have to multiply with multiplicative inverse of 5, which is nothing but 1 by 5. So, we write 1 by 5 into minus 10 less than 1 by 5 into minus 5x less than 1 by 4 in 1 by 5 into 4. So, we cancel 5 here, it is 2, we cancel 5 over here, here we cannot cancel, we leave it as it. So, we get the expression as minus 2 less than minus x less than 4 by 5. Now, we have to remove minus symbol. So, we have to multiply by minus 1 or negative sign. Okay, when you multiply by minus 1, we have to be very careful with the inequality. Whenever we multiply by a negative symbol or negative number, the inequality is getting reversed. You all know, correct? So, I multiply minus 1. So, minus 1 into minus 2 will be 2. I change the inequality symbol to greater than. I multiply by minus symbol. So, minus of minus x will be x greater than. I multiply by negative sign. So, minus 4 by 5. So, we rewrite minus 4 by 5 strictly less than x less than 2. So, what is the solution set for this problem? Solution set is open interval minus 4 by 5 to 2. 2 also open. Is it clear? We move on to next problem. Now, see this expression, modulus of x plus 1 greater than or equal to 3, modulus of x plus 1 greater than or equal to 3. Now, we may notice that modulus of x plus 1 greater than or equal to 3. We have modulus in the inequality and we are having very important thing greater than or equal to. So, whenever mod x, whenever we are having mod x is greater than or equal to a, okay, your x will be less than minus a or x will be greater than plus a. We write equal to symbol. Okay. Whenever mod x is greater than or equal to a, your x will be less than or equal to minus a or x will be greater than or equal to a. Whenever we have the inequality mod x is greater than or equal to a, okay, this inequality will be split into two inequalities. One is x less than minus a and other one is x is greater than or equal to plus a. Same way, here modulus of x plus 1 is greater than or equal to 3. Okay, because we are having greater than or equal to, we cannot solve this as single inequality. So, we have to split this into two inequalities. One is x plus 1 less than minus 3. The other one is x plus 1. Consider this problem. Solve the inequalities. Modulus of x plus 1 greater than or equal to 3. Modulus of x plus 1 greater than or equal to 3. Okay. Now, we are having modulus with the inequality and we are having greater than or equal to. Okay. How to solve inequalities involving greater than or equal to? So, we have this expression modulus of x greater than or equal to a implies x is less than minus a, less than or equal to minus a, or x is greater than or equal to plus a. Same way, to solve this inequality modulus of x plus 1 greater than or equal to 3, we have to split this into two inequalities. One is x plus 1 less than or equal to minus 3 and x plus 1 greater than or equal to plus 3. We split into two inequalities. One is x plus 1 less than or equal to minus 3 or x plus 1 greater than or equal to plus 3. One is less than or equal to, the other one is greater than or equal to. When you write less than or equal to, you have to write negative symbol, and when it is greater than or equal to, it should be positive symbol. Now, how to remove this expression? Plus 1. Now, x plus 1 minus 1 less than or equal to minus 3 minus 1. So, plus 1 and minus 1 cancel. So, x is less than or equal to minus 4, one part. The other part same way, x plus 1 minus 1 greater than or equal to 3 minus 1. Plus 1 minus 1 cancelled. So, x is greater than or equal to 3 minus 1 is 2. So, if you see this expression, one is x less than or equal to minus 4, the other one is x greater than or equal to 2. How to write the solution set? Solution set will be x is less than or equal to minus 4. What are all the real numbers which are less than minus 4? It will be minus 5, minus 6, every number which is to the left of minus 4. So, it is from minus infinity to minus 4. Because of the equal to symbol, we close the bracket here. Union x greater than or equal to 2. Which are all the number which are greater than 2? Any number which lie to the right of 2 will be greater than 2. So, we write 2 to infinity. So, this is the solution for the above inequality. Now, consider this expression, modulus of 2 minus 3x greater than or equal to 5. And again we are having the expression mod x greater than or equal to a. So, how to solve this one? We must take x less than or equal to minus a or x greater than or equal to plus a. Same way, here we are having greater than or equal to 5. So, we start 2 minus 3x less than or equal to minus 5. Okay, less than or equal to should be involved with the negative value of the right hand side, or 2 minus 3x greater than or equal to plus 5. Is it clear? Now, we must try to eliminate the 2 which is in addition, and we must remove this 3 which is in multiplication with x. So, we try to solve this. So, 2 minus 3x minus 2 less than or equal to minus 5 minus 2. So, 2 cancelled here. So, minus 3x less than or equal to minus 7. We try to remove 3. How to eliminate 3? We multiply with multiplicative inverse of 3. So, we multiply by 1 by 3. So, 1 by 3 into minus 3x will be less than or equal to 1 by 3 into minus 7. So, 3 cancel here. So, which implies minus x less than or equal to minus 7 by 3. So, we have to remove that negative symbol which appears with x. So, we multiply with minus 1. So, minus 1 into minus x. Whenever we multiply by a negative number, the inequality getting reversed, greater than or equal to minus of minus 7 by 3. So, we get x greater than or equal to 7 by 3. Now, come to the second inequality, 2 minus 3x greater than or equal to 5. Same procedure, 2 minus 3x minus 2 greater than or equal to 5 minus 2. Why we have to subtract minus 2? Because we want to eliminate 2. So, we operate with additive inverse of plus 2, which is nothing but minus 2. So, 2 minus 2 cancelled here. So minus 3x greater than or equal to 5 minus 2 is going to be 3. I want to remove 3 now. What should I do? We multiply with multiplicative inverse of 3. So 1 by 3 into minus 3x greater than or equal to 1 by 3 into 3. So we cancel 3 here. Here also we can cancel. So we get minus x greater than or equal to plus 1. But now also I don't get the value for x because I am having minus x on the left hand side. So we multiply by minus 1. So minus 1 into minus x greater than or equal to minus 1 into 1. So I want to remove negative symbol which appears with x. So what should I do now? I should multiply with negative symbol minus 1. So I multiply with the minus 1 both sides. So minus 1 into minus x. Whenever we multiply by negative symbol, the inequality getting reversed, less than minus of 1. So x is less than or equal to minus 1. So here we get x greater than or equal to 7 by 3. Here we get x less than or equal to minus 1. So what will be the solution set? X is less than or equal to minus 1. So any number which is less than minus 1 will be considered for the solution for this inequality. So it is from minus infinity to minus 1 closed. Union x greater than or equal to 7 by 3. Any number greater than or equal to 7 by 3 will be considered for the solution for this inequality. So the answer will be 7 by 3 to infinity. Is it clear? Now let us consider another problem. Here we are going to do the same thing, but we are going to mark the solution set in the number line. We are going to mark the solution in the number line. Okay. Same procedure we are going to follow. No change. So modulus of 2x plus 5 less than 3. So what are the things we see in this inequality? In this inequality we are seeing modulus symbol and we are having less than. Okay. So how to find the solution for this? How to start the solution? We must write minus 3 less than 2x plus 5 less than 3. Because whenever mod x is less than a, your x value should lie between minus a and plus a. Using this property we are writing that. So to find the value for x, first I should eliminate plus 5. So what I should do? I add with additive inverse. So additive inverse is nothing but minus 5. So minus 3 minus 5 less than 2x plus 5 minus 5 less than 3 minus 5. So this is minus 8 less than plus 5 minus 5 cancelled 2x less than 3 minus 5. So here we are having different symbol. So we subtract the smaller number from the bigger number and we write minus 2. Again we have to eliminate 2. How to eliminate? We multiply by multiplicative inverse. So multiplicative inverse of 2 is 1 by 2. So 1 by 2 into minus 8 less than 1 by 2 into 2x less than 1 by 2 into minus 2. So we get the answer as minus 4 less than x less than minus 1. So my x value is going to lie between minus 4 and minus 1. We try to draw this one in number line. Okay. So in the number line we have minus infinity, plus infinity, and we are going to mark minus 1 and minus 4. Minus 4 will lie to the left of minus 1 because minus 4 is less than minus 1. Minus 4. Now my x is going to lie between minus 4 and minus 1. So what will be the region? It will be, the solution set will be in between minus 4 and minus 1. And clearly there is no equal to symbol in the inequality, so we must not include the n values. So we put circle over minus 4 and minus 1. We are not going to shade that part. Okay, that is, it indicates we are excluding the end values. We are excluding the end values. Is it clear? So it is similar to the method which we used in the previous problems. One extra part here, what we are doing is we are finding the solution and marking them in the real line, number line. Now see the next question. Modulus of 7 minus 3x is less than or equal to 8. Modulus of 7 minus 3x less than or equal to 8. So how to find the solution for this? Again we are going to have less than or equal to. In the previous problem we did less than, here it is less than or equal to. Okay, so we start. Modulus of 7 minus 3x less than or equal to 8. So because it is less than or equal to, my solution will lie between minus 8 less than 7 minus 3x less than or equal to 8. Here also it is equal to, less than or equal to. Okay, it will lie between, that is 7 minus 3x will lie between minus 8 and plus 8. Now we have to find the solution for x. So first we try to eliminate 7. So for that we add additive inverse of 7, that is minus 7. So minus 8 minus 7 less than or equal to minus 3x, that is 7 minus 3x minus 7 less than or equal to 8 minus 7. So here plus 7 and minus 7 cancel. Here minus 8 minus 7 both are having same symbol. So it should be added. So minus 15 less than or equal to minus 3x less than or equal to 8 minus 7. 8 minus 7 is 1. Now we divide or multiply by multiplicative inverse of 3. So we multiply by multiplicative inverse of 3. So 1 by 3 into minus 15 less than or equal to 1 by 3 into minus 3x less than or equal to 1 by 3 into 1. So we cancel the expression, it is 5 times. Here 3 3's are getting cancelled, here we cannot cancel, so we leave the expression as such. So this is minus 5 less than or equal to minus x less than or equal to 1 by 3. Now we must remove that negative symbol which appears with x. So we multiply by minus 1 throughout. So we have to be very careful when we multiply by negative symbol minus 1. Why? Whenever we multiply by negative symbol, the inequality is getting reversed. So minus 1 into minus 5 greater than or equal to minus 1 into minus x greater than or equal to minus 1 into 1 by 3. So it is 5 greater than or equal to x greater than or equal to minus 1 by 3. So we try to rewrite this inequality. The inequality is rewritten as minus 1 by 3 less than or equal to x less than or equal to 5. So this is the solution set. Okay, when you write this one in interval, solution set will be, so x lies between minus 1 by 3 and plus 5 and both values are included. So we write minus 1 by 3 closed interval comma plus 5. So this is the answer. So if you want to represent this one in number line, we draw number line. So we mark the points. One point is minus 1 by 3, the other one is plus 5. This is minus infinity, plus infinity, minus 1 by 3 and plus 5. And both values are included. Because both are included, we darken that endpoints, and x is going to lie between minus 1 by 3 and plus 5. So we shade the region. Is it clear? Because x is going to lie between minus 1 by 3 and 5, we are going to shade inside minus 1 by 3 and plus 5. Okay. So the solution set for this expression, modulus of 7 minus 3x less than or equal to 8 is closed interval minus 1 by 3 and 5. Let us consider another problem, modulus of 3x plus 2 greater than or equal to 5. Okay. Now we are going to see inequality involving greater than or equal to. Is it clear? So modulus of 3x plus 2 greater than or equal to 5. So whenever we are having greater than or equal to symbol, the inequality should be separated. Okay. So how to rewrite this inequality? This will be rewritten as 3x plus 2 less than or equal to minus 5 and 3x plus 2 greater than or equal to plus 5. Okay. So modulus of 3x plus 2 greater than or equal to 5, because we are having greater than or equal to inequality, the inequality will be split into two different inequalities. One is 3x plus 2 less than or equal to negative value, that is minus 5. The other one is 3x plus 2 greater than or equal to plus 5. And we have to perform the same old procedures. So first we try to remove plus 2. So what we are supposed to do? So 3x plus 2, additive inverse of plus 2 is minus 2, less than or equal to minus 5 minus 2. So plus 2 minus 2 cancel. So we get 3x less than or equal to minus 7. Now I want to remove 3. So multiply by 1 by 3, multiplicative inverse of 3, less than or equal to 1 by 3 into minus 7. So 3 cancel now. So x is less than or equal to minus 7 by 3. This is one part. We consider the other inequality, 3x plus 2 greater than or equal to 5. We try to get the value for x from this inequality. So 3x plus 2, we add with additive inverse of plus 2, which is nothing but minus 2, greater than or equal to 5 minus 2. 2 cancel here. So 3x is greater than or equal to 3. Now I want to remove 3. So I multiply with 1 by 3. So 1 by 3 into 3x greater than or equal to 1 by 3 into 3. So 3 cancelled here. Here also 3 cancelled. Now x is greater than or equal to 1. So here we get x less than or equal to minus 7 by 3. Here we are getting x greater than or equal to 1. Okay. Now x is less than minus 7 by 3 means any value which lies to the left of minus 7 by 3. X greater than or equal to 1 means any value which lies to the right of plus 1. So the solution set will be minus infinity to minus 7 by 3 closed interval union 1 to infinity. Suppose if I want to mark this in real 9, we are supposed to mark this in real 9. So we try to write. We draw this real number, we plot it, minus infinity to plus infinity, two values of x, one is minus 7 by 3, the other one is plus 1, and both the n values are included. So first we try to shade the 10 points, and one is minus infinity to minus 7 by 3, that is x less than minus 7 by 3. So, any value which lies to the left of minus 7 by 3. So, this is the value, and x is greater than or equal to 1. So, values of x which is lies to the right of 1. So, this is the solution in the number line. So, we move on to next question. Now, consider this expression 3 times modulus of 5 minus 2x greater than 7. Okay, which can be rewritten as modulus of 5 minus 2x. Okay, how I can write this one? I multiply by multiplicative inverse of 3, that is 1 by 3, both sides. So, this 3 and 3 cancelled. So, I get modulus of 5 minus 2x is strictly greater than 7 by 3. So, it is greater than inequality. So, whenever we are having the expression mod x is strictly greater than a, we cannot solve this as combined inequality. We cannot combine the inequalities. We have to separate the inequality. How to separate the inequality? X is less than minus a and x is greater than plus a. So, we rewrite this inequality because it is having modulus, we have to separate the inequalities. So, 5 minus 2x less than minus 7 by 3, 5 minus 2x is greater than 7 by 3. Now, I want to remove 5. So, what I should do? 5 minus 2x, additive inverse of plus 5 is minus 5, less than minus 7 by 3 minus 5. So, left hand side we cancel this 5. What about the right hand side? Minus 7 by 3 minus 5. So, we must take LCM for the right hand side. So, minus 2x will be less than 3 is the LCM. So, 1 into minus 7 minus 7, 3 into 5 15. So, minus 2x is less than minus 22 by 3. Now, we try to remove this 2. So, multiply by multiplicative inverse of 2, that is 1 by 2. So, 1 by 2 into minus 2x is less than 1 by 2 into minus 22 by 3. So, here 2 cancelled, we cancel 2 over here, it is 11 times 22. So, minus x will be strictly less than minus 11 by 3, but we are having negative sign. So, we try to multiply with minus 1 on both sides. Whenever we multiply by minus, the inequality is getting reversed. So, minus of minus 11 by 3. So, minus to minus plus. So, x greater than 11 by 3. So, this part gives a solution. Any number which is greater than 11 by 3 as the solution for the inequality. Now, we try to solve the second part. Five minus 2x is greater than 7 by 3. So, we rewrite 5 minus 2x, additive inverse of plus 5 is minus 5, greater than 7 by 3 minus 5. So, plus 5 minus 5 cancelled. So, minus 2x is greater than, this 5 is written as 5 by 1. Take LCM, 3 is the LCM. So, 7 minus 15. So, minus 2x will be greater than plus 7 minus 15. Both are going to have different sign. So, subtract the smaller one from the bigger one. So, 15 minus 7 will give you the answer 8, and bigger number sign is minus. by 3. Now I want to remove 2 which is in multiplication with x. So I multiply by multiplicative inverse of 2. So 1 by 2 into minus 2x strictly greater than 1 by 2 into minus 8 by 3. So 2 to cancel. If you cancel 2 here, it is 4. So it is minus x greater than minus 4 by 3. I multiply by negative symbol or multiply with minus 1. So minus 1 into minus x will be strictly greater than. I multiply by minus 1. So minus 1 multiplied with the minus x. Whenever we multiply by negative symbol, the inequality is getting reversed. So it is less than minus 1 into minus 4 by 3. So minus to minus plus. So x is strictly less than plus 4 by 3. So here we are having one expression and here we are having another one. So x greater than 11 by 3. Here x is less than 4 by 3. So in number line, we are going to mark the solution. Okay. Number line we are going to mark. Of these two number, 11 by 3 and 4 by 3, which is smaller, which is bigger? Both are going to have same denominator, correct? Both are going to have same denominator. The number which is going to have higher numerator will be greater. Is it clear? So 11 by 3 will be lying here. Minus into plus infinity. So we mark 11 by 3 on the right hand side and 4 by 3 to the left hand side. And it is going to be a strict inequality. So we are not supposed to include the end values. So 11 by 3 is excluded. Eleven by 3 is excluded, and here also 4 by 3 is excluded, and x is greater than 11 by 3. So any number which is going to lie to the right of 11 by 3 will be marked, and x is less than 4 by 3. Any number which is less than 4 by 3 will be marked here. So this is the answer. The solution set will be minus infinity to 4 by 3 closed union 11 by 3 to infinity. Is it clear? Now we are going to see some special cases involving modulus inequality. Now we are having a typical question here. Modulus of 2 plus 3x is strictly greater than 0. What are the values for x which will satisfy this expression? Okay. Now we used to have, when mod x is strictly greater than a, x will be greater than plus a or x will be less than minus a. But in this particular case, we are going to have 0. Is it clear? We are going to have 0. It is not any numerical value to write it as minus a and plus a, because 0 and minus 0 both are going to be same. So, the typical answer for this expression in simple word, it will be except the value of x which will make this inequality to be equal to 0. But we try to solve by usual method. Okay, we take 2 plus 3x greater than 0 or 2 plus 3x less than 0. Is it clear? Now, 2 plus 3x minus 2, additive inverse of plus 2 is minus 2. So, 0 minus 2, 2 cancel. So, 3x is less than minus 2. I want to remove 3. So, we get multiply by 1 by 3, 1 by 3 into 3x less than 1 by 3 into minus 2. So, 3 cancel. So, x is less than minus 2 by 3. Okay, x is less than minus 2 by 3. If you take this particular part, 2 plus 3x greater than 0, 2 plus 3x minus 2 greater than 0 minus 2. 2 cancel. So, 3x is greater than minus 2. To remove 3, we multiply by multiplicative inverse. So, 1 by 3 into 3x strictly greater than 1 by 3 into minus 2. 3 cancel. So, x is greater than minus 2 by 3. So, here we are having x less than minus 2 by 3 and x is greater than minus 2 by 3. So, the solution set will be minus infinity to minus 2 by 3, okay, open, union, minus 2 by 3 to infinity. I already told you the solution set for this inequality will be the values of x which will be making this inequality to be equal to 0 alone to be omitted. So, when you solve for the value of x which makes this expression 2 plus 3x to be equal to 0 will be 2 plus 3x minus 2 will be equal to 0 minus 2. So, 3x is equal to minus 2. So, 1 by 3 into 3x will be equal to 1 by 3 into minus 2. So, x is equal to minus 2 by 3. So, this particular value of x alone should be omitted in the solution set. That is what we are getting here. So, this is a typical value, typical question, modulus of 2 plus 3x strictly greater than 0. And see this one. Usually in the inequality we used to have the numerical part alone on the left hand side or the right hand side, on the side of the inequality. But here we are having 8 plus 3x less than modulus of 8 plus 3x. Okay. We have seen one property in the introduction part of the solving inequality with the modulus. X less than mod x. It can happen only when x is strictly less than 0. Whenever x is less than 0, whenever x is negative, then x will be less than modulus of x. So, we apply this formula here. So, 8 plus 3x less than modulus of 8 plus 3x implies 8 plus 3x is strictly less than 0. So, we try to get the value for x. So, 8 plus 3x minus 8 less than 0 minus 8. We add with additive inverse of plus 8. So, 8 minus 8 cancel. So, 3x is less than minus 8. We try to remove 3 which is in multiplication. So, by multiplying 1 by 3 we remove this 3, less than 1 by 3 into minus 8. So, 3 3s are cancelled. So, x is less than minus 8 by 3. So, this is the solution set. So, when you want to write this one in the interval form, the solution set will be minus infinity to minus 8 by 3, open interval. The end values should not be included. Okay. Now, again we are going to solve this inequality which will have modulus on both the side. Okay. So, here we are having the part modulus of 5x is less than modulus of 10 minus 5x. Okay. Here in this particular inequality, we are having modulus on the left hand side as well as on the right hand side. So, to solve this particular inequality, we are going to make use of the property mod x is strictly less than mod y if and only if x square is less than y square. X square should be less than y square. So, apply the property now. So, LHS we are having 5x, right hand side we are having 10 minus 5x. So, this implies 5x the whole square strictly less than 10 minus 5x the whole square. This implies 5x whole square, it is 25x square strictly less than. We try to remove, we try to expand 10 minus 5x the whole square. So, using the identity a minus b whole square. So, we get 10 square minus 2 into 10 into 5x plus 5x the whole square. So, which implies 25x square strictly less than 100 minus 2 into 10, 20, 20 into 5, 100 plus 25x square. We have 25x square on the left hand side as well as on the right hand side. So, we remove them by adding with the additive inverse of them. So, minus 25x square strictly less than 100 minus 100x plus 25x square minus 25x square. So, 25x square cancel, 25x square cancel. So, we get 0 less than 100 minus 100x. Now, I want to remove this 100. So, add the additive inverse of 100 on both sides. 0 minus 100 less than 100 minus 100x minus 100. So, 100 cancel here. So, we get minus 100 strictly less than minus 100x. Now, I want to remove this 100. So, multiply with multiplicative inverse of 100, that is 1 by 100 multiplied with minus 100 . We multiply with multiplicative inverse of 100, which is 1 by 100 multiplied with minus 100 less than 1 by 100 multiplied with minus 100x. So, 100 cancel, here also the 100 cancel. So, we get minus 1 strictly less than minus x. How to solve this expression now? Again we have to remove minus symbol. So, we multiply with the minus 1. So, minus 1 into minus 1, this less than will be changed to greater than, minus 1 into minus x. So, we have to rewrite this expression, minus to minus, this will be plus x, and which will be less than, minus to minus plus 1. So, this is the solution set, x is less than 1. So, the solution set will be minus infinity to 1, open interval, 1 is not included. Is it clear? Now, in this problem, we are making use of this identity, mod x is less than mod y implies and implied by x square is less than y square. This is possible only when x square is less than y square. We are going to see one more problem of the same type. Here consider the another problem, modulus of x minus 3 less than or equal to modulus of x plus 2. Now, tell me which property we are going to use, because we are having modulus on both the sides of the inequality. Which property we are going to use? Yes, exactly. We are going to make use of the property modulus of x less than or equal to modulus of y if and only if x square is less than or equal to y square, and if and only if can be rewritten as implies and implied by. So, make use of this. So, here modulus of x minus 3 is less than or equal to modulus of x plus 2. This is possible only when x minus 3 the whole square is less than or equal to x plus 2 the whole square. Okay. Which implies we apply formula for this identity. So, we get x square minus 2 into x into 3 plus 3 square less than or equal to, this is a plus b whole square. So, x square plus 2 into x into 2 plus 2 square. So, simplify this expression, x square minus 6x plus 9 less than or equal to x square plus 4x plus 4. So, we cancel x square and x square on both the sides by adding additive inverse of x square. So, x square minus 6x plus 9 minus x square less than or equal to x square plus 4x plus 4 minus x square. We cancel x square, x square, x square, x square. So, we get minus 6x plus 9 less than or equal to 4x plus 4. Now, we must remove this 9. How to remove this 9? Minus 6x plus 9 minus 9 less than or equal to 4x plus 4 minus 9. So, 9 cancel. So, we get minus 6x less than or equal to 4x plus 4 minus 9, which is nothing but minus 5. Now, I want to eliminate plus 4x on the right hand side. So, additive inverse of plus 4x is minus 4x. So, we add by minus 4x both the side. So, 4x minus 5 less than or equal to, sorry. So, to remove 4x which is on the right hand side, we add with additive inverse of 4x, that is minus 6x minus 4x less than or equal to 4x minus 5 minus 4x. So, 4x cancel. So, when you simplify this expression, minus 10x is less than or equal to minus 5. Now, we divide by 10. that is we multiply by multiplicative inverse of 10, that is 1 by 10 into minus 10x less than or equal to 1 by 10 into minus 5. So 10 cancel, here 1 5s are 5, 2 5s are. So minus x is less than or equal to minus 1 by 2. Now we have to multiply by minus 1. So whenever we multiply by minus 1, the inequality is getting reversed. So minus 1 into minus x will be greater than or equal to minus 1 into minus 1 by 2. So minus minus plus. So this is x greater than or equal to 1 by 2. So this is the solution set. So any number which is greater than 1 by 2 will be considered as the solution for this inequality. So the solution set will be written as closed interval 1 by 2 to infinity. Okay, students. Now in this session we have learnt what is the modulus of a number, how to solve equality involving modulus, that is modulus equations, and we have learnt how to solve inequalities involving modulus. Okay. Thank you, students. We will see in yet another program. Thank you.